So in addition or in elaboration to what I've discussed in the last video, it's the third part of the series, the guns, steel and bot series. So I mean, as I said, it's not. I mean, the fact that we've seen bots in large quantity, mostly duds, but also real one probably, inside the foam, when foam is created surrounding the electrolysis rods, doesn't necessarily mean that the foam itself is something that is required, or that the process of creating the foam is a substantial part of the process. I would suggest probably it's a harmful byproduct, because I mean I don't think that all this heat that is generated is generated by the neurons themselves. My guess is that they are generated by electrolysis. I mean, it's a process that is, and also the separation of liquid to other elements. It's something that takes. I'm not sure that they're even needed at all. And in the erosion of the metal and galvanization. I mean, there are all sorts of processes that spark well like it happens in the electrolysis chamber. And I would suggest that probably they are not needed and even harmful. And also, of course, I mean, the critical point is that, I mean, when the foam is created in large quantities, pretty soon, I mean, temperature rises and it starts to burn. So I've actually changed a couple of hours ago. I changed like a little bit the symbols, and this is kind of like, I mean, it's a new concept. I mean, it's a kind of like, I mean, a synthesis of several like symbolic concepts. Let's discuss it some other time. I don't want to deal with everything not all at once. But anyway, what's for certain is that this liquid is less conductive than before, because I've added like both paint and a little bit of silicone that I have, like the polymer that I have, and also salt in large quantities. So it's much less conductive, and also we have like we have several new rods that are now deeper. When the rods are like as deeper they are, I mean it's it takes, I mean, burning is the burning is mostly, I mean, it's I don't really know why. I mean, I can formulate a theory, but out of like just from the sleeve. But I mean, it's burned the hardest when the rod barely touches the water. I mean, when it's like almost fully eroded. When it doesn't touch, I mean, after some time, I mean, it's so much eroded that it doesn't touch the water, and then there is no electrolysis, at least not from this rod. There can be other rods, like in this case that we have 10 rods actually, or like even 10 or 11 rods. But I mean, it's burned the hardest, like when it touches. I mean, when it eroded enough that it's almost not touching, but it's still touching the water. We can think like together why it happens, but that's the way it is. So if we replace it with new rods, I mean, that are deeper into the mixture, but still not. I mean, they shouldn't touch like the magnet or the pot, because then it's shortcut. But if you do it, I mean, you have more time like before it starts to burn. But I mean, more substantially, that I paralleled the negative, like the neutral, the black. No, the neutral is the white, not the black. Rod to see that you have 4 circuits, and you have six rods of the hot ones. So I mean, that many rods, of course. I mean, we have. I mean, obviously, each of them is so. I mean, so we have like, I mean, 6 circles, like, I mean, six circles, and like 4 like sinks for the current, and of course, so it's less energy for each of them, and of course much less heat. So all the factors together, I mean, obviously, as expected, this whole pot, and also there is like water cooling now. It's not ice no more. It's just, I mean, now it's just almost room temperature. So for the next experiment, I'll probably replace it with new water from the freezer. But I mean, as expected, it's now. It burned significantly less. I mean, we had significantly less foam and also less burning, and no. Even though it was connected for a couple of hours now. Well, actually, I stop it now. Still, I mean, no signs of burning. But does it mean that actually less work has been done? I'm not sure. I mean, obviously, I will now check it under the microscope. I'll take a few samples, a few slides, and I'll see what's going on. And there could be, issue with the symbols, and need to take it into account that it's different symbols. So, but maybe, it's a whole new different thing, and maybe they don't. Something. The neurons worked on something completely different. But again, the form itself, the separation of liquid to its element, I don't think that it's happened by the neurons do it. And why should they? It's not needed. I don't see why it's needed, and we know that it's part of. It's essential. It's natural things that happens when you do electrolysis without relation to the neurons. The separation of the liquid to its element. It's one of the basic usages. Maybe the first one of electrolysis was to separate water to hydrogen and oxygen. Yeah, but it's just an example. There is a ton of other usages, and I would suggest that these usages are not. Maybe they are helpful for the neurons, or maybe they are helpful for. In order to create something. It's like a very general. They can work on pretty much everything. So maybe for some. Maybe if it's actually, they have problem with oxygen. Oxygen kills them in high quantity. But for example, maybe if they need hydrogen, for example, so yes, the separation of the liquid to hydrogen atoms. It's actually H2, I think. Hydrogen molecules, like double molecule, but double atom molecule. But maybe it's helpful, but not in the general sense. So the fact that we don't, as I said, we don't see a lot of form, a lot of separation of the liquid into different molecules doesn't in itself say that it's that this compartment is essentially undoubtedly less effective than when the mixer was much more conductive, as it was the case before I've added all the material that is aimed to reduce conductivity. In any case, I will in a couple of minutes I will take samples under the microscope and we'll see how it goes.